So we are currently in the Bond ADCO Amphitheater, about to go in the FinTech Hub. And let me talk to you a little bit about this FinTech Hub. It is actually home to 40 Bloomberg terminals. And let me explain to you. Essentially, these are the world standard for professional and professional accountants as well as financiers who are looking to kind of work in the space. So our students actually work on these terminals throughout their degrees. And what I'd say is, guys, there's 40 of them. It's the most any university houses. So this area we have just entered is the Bond FinTech Hub. It's made up of two different areas. It's actually our dealing and trading room. And please understand, this does not deal with the casino, okay? So we are about to pop in and we are going to meet with our Associate Dean, Mr. Bruce Vanstone, who's going to talk us through the FinTech Hub a bit. So come on with me. Bruce, so very good to see you, my friend. Thank you for welcoming us.
Hi, Sean. Good to see you again.
Absolutely. So, man, this place is something special. I see a ticker kind of going on outside, two separate rooms. We're on the beautiful campus. So can you tell me a little bit about what goes on kind of in this area?
I can, Sean. This is the trading room, the Bloomberg trading room. It's a fantastic resource for students. It contains a huge database of historical information that we use for a variety of different subjects. In Bloomberg, you'll find things like news information, sentiment information, even tweets that people make about companies, let alone all the information about listed companies, their prices, their historical returns, their boards of directors, news articles about them. It's just an immense database source. And students would use that in all sorts of different ways. For example, in finance, when we care about CAPM, you'd be wanting to get things like market returns or company-specific returns. Accounting, where we might be valuing companies, for example, we care about historical ratios and how they've changed over time. Have access to things like the balance sheets, the profit and loss statements, the income statements, all those kind of articles are on there. Other things that are on there, I mentioned before, the news articles, for example. So everything that comes up in a newspaper about a particular company is recorded, along with tweets that people make. And we use this kind of area in big data. That kind of thing is used for sentiment analysis, which feeds things like high-frequency trading strategies and things like that. So it's just an incredible resource.
And so this would cross over probably almost all the, you have your business, you have your commerce side of things with finance and accounting. I mean, it sounds like there might be a lot of crossover between students maybe working together, seeing different sectors.
Absolutely. All students who go through the business school will have in some way have access to these terminals or some usage of them. For example, students who are doing the Fundamentals of Finance course will do a Bloomberg Market Certificate, which is a publicly recognized certificate issued by Bloomberg to say that you're familiar with using the terminal.
And so you get another added bonus for that. All right,
just another one.
This is all awesome, but I know you have a demo for us. It's really going to probably take us through it and give students more example of what we're talking about. So I'm going to sneak around. I know we're kind of in our COVID and we want to stay safe, so I'll stay distant, but I'll sneak around really quick and maybe you might be able to show us.
So the course I'm teaching at the moment is a machine learning and business course, and this is one of our students, Nikki. So this is a little bit of an explanation about the demo we're going to show you. On one side of the screen, the left-hand side, you can see the equivalent of a biological neuron, and the right-hand side is the computer equivalent of that idea.
And just to step in real quick, guys, I want you to know this should be on your screen, hopefully, if you're tuning in at home. So just make sure you're looking out for that. Sorry, back to you, Bruce.
Oh, you're right. So the left-hand side represents a human neuron, for example, in the brain, and electrical discharges come along through those dendrites and they flow down through the axon, and they come out at those axon terminals, where they then jump to numerous other dendrites that are in close proximity. And the idea is that things happen in parallel in your brain. So the human brain has trillions of these things. And effectively what happens is that this electrical signal spreads out throughout your brain, and that's how you make decisions. And so, for example, the computer has a lot less neurons, but is a lot faster. So the human biological equivalent's reasonably slow in biological time. And they say it takes about half a second to do your most familiar task, which for most people is recognizing their own mother. On the right-hand side there, this is the kind of computer equivalent. We have a number of different inputs on one side. They're multiplied by a set of weights, and they go through a transfer and an activation function, and they come out the other side, adjusted. And Nikki, if you just jump to the next slide for me. So this is an example of a deep learning neural network. And what it is a whole pile of those different right-hand side neurons that we just saw there before, a whole pile of those clustered together in layers. And there are millions and millions of those free parameters or weights that need to be learnt. And the idea is to have your inputs come in on one end, and then these huge numbers of different weight manipulations go along, and the prediction comes out the other end. Nick, if you could just jump forward. So for those who are interested in their IT and their maths, for example, this is a process called backpropagation and gradient descent. And realistically, the training process works by using a whole pile of derivatives of the different layer functions, the activation functions, and they all get put together in a chain rule to try and find the global optimum for the whole process. It kind of works a little bit like this. The inputs come in, and each layer, which is filled with those neurons and has a whole pile of those free weights, initially the weights are randomly set, and then the machine makes a prediction from the random weights and compares it to the actual answer, and then tries to use gradient descent to go back and adjust the weights to make the solution better. And it kind of iteratively goes round and round and round until you get within a degree of tolerance that you're happy with. So that's the kind of thinking process of how it works. One of our other students, James here, is just experimenting with the idea right now.
Oh, let's have a look. Yeah, that sounds good.
So as Bruce said, we've got that VGG16 model, which is really complex and hard to build, but we can just load it in from the internet, like we've done here. And it's really good at looking at different pictures and trying to classify what they are. So here we have a couple of images on our machine, and we can start looking at, for any given image, what would the network or model be predicting. So here we have a picture of 2 elephants, and just running this chunk of code here, we can see the top 3 predictions it's making. So it thinks it's probably an African elephant with a 93.5% chance, and then a couple of other species of elephant after that. But these models tend to be really hard to understand how they're making predictions. So we tend to look at, for a given image and all the pixels in it, where are we seeing the strongest response? So we can kind of understand how it's making these predictions. So looking at this image now with a heat map of where we're getting strong responses from the network, we can see that it seems to be looking at their trunk, where their tusks are, their flappy ears. And so that's how it's saying, well, it has these 3 characteristics. It's probably an elephant. So that's really useful for understanding how it's doing what it does.
It's amazing.
Thanks, James. So students would use this kind of thing in class. They'll build their own networks, initially to tell the difference between things like cats and dogs. But out in a real world, we might want to classify customers. We might want to think about what customers are looking at, whether they're happy or they're sad, or their propensity to buy. Even this kind of technology you'll find in things like driverless cars, for example.
And it's incredible because, I mean, I think even in the space we're in, a lot of companies are going to try to figure out how happy are our customers, or how good is our business model working, or things like that. And this seems like very much, it dives deep, digs into what you can really find. So, absolutely, Sean. Man, this is great stuff. And again, I am not a finance or accounting person, but I will tell you, this stuff excites me just being kind of around it. So I appreciate, the students, yourself, opening up kind of the center for us today. And guys, again, students looking at business, commerce, our actuarial science, we have postgrad. Guys, get excited about this stuff. It's really cool.